In this class we are going to discuss about fundamentals of Boolean algebra. These fundamentals are very important when we are solving Boolean expressions. To solve any Boolean expression we need to apply this fundamental to get the answer easily. So, see the fundamentals of Boolean algebra here. First one is a plus 0 is there, then we can take it as a plus 0 is equal to a. Why we are taking a plus 0 as a means, for example, in case of a, if you are representing that as 1, for example, a is equal to 1, 1 plus 0 is equal to 1 only. So, that means if a is equal to 1, then 1 plus 0 is equal to 1. You are getting a only, whatever a is there you are getting a only. So, for example, a is equal to 0, then in a plus 0 plus 0 you are substituting, you are getting 0. So, in these both cases, so a is having only two possibilities, either 1 or 0. If a is 1, again you are getting 1, a is 0, that is 0. Whatever a you are taking, that is coming in the output. So, that's why a plus 0 is nothing but a, we can write like this. So, now 1 into a is equal to a, 1 into a is equal to a. This is also solved by using this theory. So, that means for example, a is equal to 0, you are getting 1 into 0 as 0, and for example, a is equal to 1, 1 into 1 you are getting 1. So, whatever a you are considering, that only you are reflecting as the result of this expression. So, 1 into 1, that means 1 into 0 is equal to 0, 1 into 1 is equal to 1. These are the a values. If a you taken like 0, you are getting 0 only. If you are taking a as 1, you are getting 1 only. So, that is why 1 into a is also equal to a. So, now a is equal to 1, then a bar equal to 0. Always we know that complement of anything is equivalent to its negative value. That means for example, if you taken 1, the complement is 0. If a is equal to 0, complement is 1. So, third property is, fourth property is a plus a is equal to a, fifth is a into a is equal to a. These two are called as idempotent laws. These are also called as idempotent laws. Now, we are going to solve these two also, how we are getting a plus a is equal to a. We know a plus a is equal to a, but how? So, here to solve that I am considering this here a plus, for this a I can take a plus a bar also. For example, if you are having a plus a here, I am just considering into 1. Into 1 means a plus a bar I can take. A plus a bar is equal to 1, because so here a plus a bar means, for example, a is equal to 0, definitely a bar is 1. If a bar is 1, if a is 1, a bar is 0. In any case of a, the value is equal to 1. So, if I multiplied anything with 1, we are getting same thing by using this. So, that is why I am just taking a plus a into a plus a bar like this to solve this. So, here I am just multiplying a into a. So, is equivalent to a only. Again a into a. Again equivalent to a only. So, next again a into a bar is equivalent to 0. Again a into a bar is equivalent to 0. So, now you are getting a plus a. When you are getting a plus a, you can take common of a. So, you can have 1 plus 1 there. So, that means again you are getting a plus a. So, you can take common of a in this 2, you are getting 1 plus 1, 1 plus 1, logical 1 plus 1 is equivalent to 1 only, a into 1 means a again. So, now no need to take this also, by here itself you can take common of a. So, you are having 1 plus 1, when you are having logical 1 plus 1, the value is 1, 1 into a is equal to again a like this. Now, you can take a into a equal to A. A into A is equal to A means here also you are having one equation, that means you can take A into A. So, into A bar you can take like this. To solve this A into A, I am adding a 0 here. Is there any difference? By adding 0 to the LHS, is there any difference? No difference, right? So, for this 0, I am going to add A into A plus A into A bar. So, 0 is, I am taking like A into A bar. Now, see here, we can take common of A here. So, if you taken common of A, what you are getting means A plus A bar. Again, A plus A bar is equivalent to 1 here, because if A is 0, A bar is 1. If A is 1, A bar is 0. So, like that, in any way, in any case of A, this value is equivalent to 1. So, this is equivalent to A. So, like this we can solve this. Similarly, A into 0 is equal to 0. This is another fundamental we can use by solving Boolean expressions. When anything multiplied with 0, that will reflect 0 only. Next, we are having absorption laws like A plus AB is equal to A into A plus B is equal to A. So, here you can just take common of A. So, that means A into 1 plus B will come. So, this is equivalent to 1 plus anything, 1 plus 1. For example, if B is equal to 1, 1 plus 1 is equal to 1 only. If B is equal to 0, 1 plus 0 is also 1. So, A is multiplied with 1 always. So, definitely the value is equivalent to A here. So, in the same way, so see this second absorption law. So, here A into A is equal to, I am just multiplying to inside. A into A is equal to A, next plus A into B is equal to AB. So, here this is nothing but this law. So, definitely this is equivalent to A here. I am just multiplying to inside, that is it. So, now see here last two fundamentals. This is A plus A bar B is equal to A plus B. This is very important fundamental that you are going to use mostly in Boolean expression solving, and it came directly in gate questions in one of the years of gate problems. So, it came directly. So, what is the value equivalent to A plus A bar B? So, that is equal to A plus B. Here what you need to think is anything added with multiplication of its complement and other number, then definitely you are having A plus B. For example, if you are having like this, that means x plus x bar c, like this if you saw anywhere. For this x you are having complement here. So, this complement multiplied with some other thing. So, you can take this as x plus c. For example, if you are having like this A plus C plus A plus C into B, like this you have an expression A plus C bar into some B is there. So, now, so here you for this is the complement, for this complement something is multiplied. So, now you can take this as A plus C plus B. So, you can apply this fundamental like this. So, now we can see how we can solve this. So, I am taking here, I am just adding, I am just multiplying 1 plus B for A. To solve that, I am just doing, so multiplication of 1 plus B here. See here, I am considering this A plus A bar B I am considering. Now, for this I am just multiplying 1 plus B. You know the value of 1 plus B, 1 plus anything is equal to 1 only, 1 plus some long expression is also 1. So, 1 plus anything is 1 plus A bar B. So, now see here A into 1 A, next A into B A B plus A bar B. Now, I am taking common of B in these two. So, now, so here I am taking common of B, A plus B into A plus A bar. So, here a plus a bar value is equivalent to 1. You know the value of a plus a bar. So, that is equal to 1. So, this is nothing but a plus b. Like this we can solve this expression. So, a plus a bar b is always equivalent to a plus b. In the same way, here also see a into a bar plus b is equal to ab. We can say this is dual of this expression. Whenever you are having plus, you are getting multiplication, and whenever you are having multiplication, there you are getting plus. This is nothing but dual of expression. Dual means or converted into and converted into or, plus into multiplication, multiplication into plus. So, now here you are having dual of this expression. So, simply this expression is also going to dual, that means plus into multiplication. So, generally we can solve like this: a into a bar is 0, a into b is equal to ab. Simply we can solve that. These are the general fundamentals we need to use in Boolean algebraic expressions.